Okay, students, this is the STAAR Skills Test 1H solutions video. We will begin with number 1. If f of x equals negative 1/7 x plus 4, what is the slope of a line perpendicular? When you see the word perpendicular, take note. Okay, this is important information. If you have a highlighter, I would highlight the word perpendicular. Remember that the slope of a perpendicular line is equal to the negative reciprocal of the slope of the initial line. So we call that slope m, and it's important for us to know exactly what that slope is. So in this problem, in the function, we have f of x equals, and then this is a slope-intercept form. So it's mx plus b. So this negative 1/7 right here, that's m. Okay, this is m. And if that's m, then 4 must be b, the y-intercept. This is b. So that's y equals mx plus b. So what we want to take away from this is that we're going to write down this. If m equals, and then we look over here and see what it equals, negative 1/7. Negative 1/7, then the slope of the perpendicular line, which would be the negative reciprocal. Okay, let's talk about what reciprocal means. Reciprocal means you flip the fraction, or some people say invert, I-N-V-E-R-T, or flip. So if the slope m is negative 1/7, then the negative reciprocal slope, which would be, we write negative m raised to the negative 1 power. That's the negative reciprocal slope. Negative m raised to the negative 1. The negative reciprocal slope is equal to, so here's what we're going to do. We're going to flip that fraction. So instead of writing 1/7, we'll write, instead of writing negative 1/7, we'll write negative 7/1. But we have to remember, it's the negative reciprocal. See, negative 7/1 is just the reciprocal. We need the negative reciprocal. So we have to change that sign from negative to positive. So the slope of the line perpendicular to a line with a slope of negative 1/7 is 7/1, which can be written as 7. So the slope of our perpendicular line is 7. This is your answer that goes in a box. Number 2, what is the x-intercept? Okay, in this problem, they very helpfully put labels for the y-axis and the x-axis. All right, and what we're interested in is the value associated with the x-axis. So where does this line right here intercept the x-axis? Well, it intercepts it at 3. So we'll write the x-intercept, which we can abbreviate INT, equals 3. Or you could write xint at, open parentheses, 3, 0. What this means is when y is 0, x is 3. So either of these would be fine. Both would be even better. So I'll just put the whole thing in a box. Right? But the key point here is that it's 3. All right. Number 3. Is this a function? All right, when we're examining something to see if it's a function, it's almost entirely, almost always the case that these y values are irrelevant. We want to see whether any of these x values repeat. Remember, and this is crucial, the x cannot repeat. If the x repeats, it breaks the vertical line test. So we have to see if the x's repeat. So do I see any other 1s? No. How about 1.5? Well, I don't know because I have 2 fractions here. And I need to know what these fractions are as decimals because that's a decimal. Or I can turn that into a fraction. So that's what we're going to do on the calculator. Let me flip my screen over to show the calculator. And make sure your memory is cleared. Go to the home screen. And first, let's turn 1.5 into a fraction. So we'll click 1.5, enter. Now that that's entered into the memory, we can click Math, and it's already on frac, so it's going to convert it to frac. Okay, enter, and it converts it to 3/2. Conversely, we could have placed our fraction in here and converted it to a decimal. So let me show that. If you want to start with the fraction and go to a decimal, go over here to the alpha key and click alpha y equals. And you click this one for numerator over denominator, and it's going to give you this look. So you just click enter, and then put in there 3/2, and click enter. Okay, so now that's the fraction. We want to see what that is as a decimal. Click Math, and then go down to 2 to convert it to a decimal. And you get 1.5. You see, so that's how we change back and forth. The other fraction that we were given in that x domain was 4/5. So we could just take 4 and divide it by 5 and see what we get. 0.8, all right? Or you could enter 4/5 as a fraction. Again, that alpha y equals enter. Put that in and then click Math down on decimal, convert it to a decimal. So now that we've taken a look at that, you've noticed that 3/2 is equal to 1.5. So let me flash back to the workspace. We have here 1.5, and that is equal to 3/2. So we say because 1.5 equals 3/2, this is not a function. Okay, and it's good to kind of write it out in more or less a full sentence. All right, that's number 3. Let's move on to number 4. We are asked to sketch and shade this linear inequality right here. this is a linear inequality. So linear inequality. I know it's an inequality because there's an inequality symbol. So what I have to do, the very first thing I have to do is get y by itself. Okay? So when there's an x and a y, you're usually trying to get y by itself. So we have to kind of move some things around to get y by itself on the left side. And remember, flip the sign if we have to multiply or divide by a negative number. So first we have to solve for y, or get y by itself. And to do that, we'll start by moving the 3x over to the right side. And we'll do that by subtracting, because right now it's positive 3x, so we'll put minus 3x, and then to keep the equation in balance, we'll minus 3x on the right. Now on the left side, 3x minus 3x is 0, so that kind of cancels that term out. And then we have negative 4y greater than. And remember, the order is kind of important here. We want the x term up front with the number that's stuck to it. So we put minus 3x and then minus 12. Okay, so we're almost to y by itself. We just have negative 4 times y. Remember, there's a little multiplication sign right there between the negative 4 and the y, and between the negative 3 and the x. There's a little multiplication sign. So we're going to do the opposite of multiplication, which is division. So we'll divide every term. Every term. In order to keep the equation in balance, we have to do it to every term. We're going to divide every term by negative 4. On the left side, negative 4 divided by negative 4 is just 1, so it kind of cancels them out. Now you have what you wanted, y by itself. You have y, but remember, alert, we divided by a negative. So when we divide by a negative, we got to flip that sign. Right now it's greater than, so it will become less than. And now we have to actually do this division. Here I've got negative 3 times x divided by negative 4. Now that's another way of saying that is negative 3x over 4, or negative 3 over negative 4 times x. So if any of that sounded confusing, all you're going to do is look at this and say, I've got a negative 3 over a negative 4. So they cancel the negatives. A negative divided by a negative is a positive, so you have y is less than 3 over 4 x, so 3/4 x, and then negative 12 divided by negative 4 is positive 3. So it's y is less than 3/4 x plus 3. Now we need to graph that. So one important thing to notice is that the y-intercept will be at 3, and the slope is 3 over 4. Okay? 3 over 4 is the slope. That means the rise is 3, rise over run. When we graph this thing, we'll start at the y-intercept of 3, and then we will go up 3, and then over to the right 4. Okay? Rise 3, run 4. So let's do that. Let's sketch a very basic graph. It doesn't have to be super artistic, but make sure you label your axes, y and x. Label the origin. And now we need to make some little marks. 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7. Just like that to give us an idea of what we're doing. We're going to start at 3. Now, an important thing to note, this is a less than symbol. So this is a less than symbol. I'll write it out. Less than. So when we see a less than symbol, we know we're going to have a dotted line, and we know that we're going to have open circles on that line, and we know that the shading, because it's less than, will be below the line. Okay, there's your guide. And so now we're actually going to graph this thing, and we start at the y-intercept, which is 3. So 1, 2, 3 on the y-axis. Put an open circle at 3. And now we're going to go up 3 to the right 4. So starting at 3, we go up 1, up 2, up 3. And then to the right, 1, 2, 3, 4. Okay, about right there. Put an open circle approximately where it should be. And then you need a straight edge. Come in here and connect the dots with a dotted line. Just like that. Okay, and now it's time to shade. So we said we're going to shade below the line. So we'll shade below the line. And that's it. Number 5. What is the solution to, and then you're given an exponential function. Okay, this is an exponential function. Those are the functions that look kind of like this, and I'll draw a real small graph here just to show what it does. It starts off low and it goes up like that. That's an exponential function. 7.2 is the y-intercept. And the rate here, 1 plus r, so it's 1.09. That must mean the rate is 0.09, which as a percentage would be 9%. So starting at 7.2, this grows at 9%. Okay, and then x is the exponent. This is going to be some kind of time or independent variable. So here's the thing. We are given this piece of information. What is the solution when x is 0? Now we actually do not need a calculator. We are given this little piece of advice down here. Remember the 0 exponent rule. Hey, well, some of you may be asking, what is the 0 exponent rule? The 0 exponent rule says that anything, call it a, raised to the 0 power equals 1. Literally anything. So let's take a look at our function. We have f of x equals 7.2, open parentheses, 1.09, close parentheses, raised to the x. And it's saying where x equals 0. Okay, what's the solution? So we will actually compute f of 0. And everywhere we see an x, we will replace it with a 0 and see what happens. F of 0, 7.2 stays the same. Open parentheses, 1.09 stays the same. But we're going to replace that x with a 0. Okay, now we have to remember PEMDAS. Okay. Remember PEMDAS. Your order of operations will save you here. what I noticed some students doing is first thing they were doing is multiplying 7.2 by 1.09. Don't do that, because right now you've got to deal with this parentheses and then the exponent in that order, and then you can deal with the multiplication. Okay, so right now we don't care about the 7.2. We're just focused on 1.09 raised to the 0th power. Well, in this case, 1.09 is the a value, and it's raised to the 0th power. So 1.09 raised to the power of 0 equals 1. So this means that this whole thing is equal to 7.2 times 1. Because 1.09 raised to the 0th power is 1. Okay, and that equals, we don't need the 1 there, 7.2 times 1 is just 7.2. Now, if you didn't know that, if you didn't remember the 0 exponent rule, you could do it in the calculator. And so we'll show that really quickly. We can do this in a number of ways. Let me clear the screen here. And I'll show this two ways. First, we'll do it on the main screen. Type in 7.2, open parentheses, 1.09, close parentheses, and then click this little button right here, caret, and that puts you up into the exponent territory. And instead of clicking X, put a 0, all right? And then hit enter, and you get 7.2. If that didn't float your boat, you can click Y equals and put the same thing in there, but this time we'll put the X. You could put 7.2, open parentheses, 1.09, close parentheses, raised to the X value. And now click second graph. And look, where X is 0, Y is 7.2. You can even look at this on the graph. Where X is 0, Y is 7.2. Okay? In other words, it's the y-intercept. And I hope that makes visual sense to you. All right. So we'll go back to our work surface. And this is the answer, 7.2. We'll put that in a box. And move on to number 6. Find the solutions of, and then you're given a quadratic function in factored form. So this is the factored form of a quadratic function. And what we want to know is what the solutions are. Okay, remember the solutions are where this function crosses the x-axis. Okay, so when I see the word solutions, I'm thinking of x-intercepts. So I'm looking for the x-intercepts, and there's going to be 2 of them with quadratics. So when we solve these symbolically, okay, using this notation here, if it's in factored form, that's great because we don't have to factor it. We can just take these factors, x minus 10 and x minus 1, and we can set them equal to 0, and then just solve for x. Okay, so to get x by itself, I'll add 10 to both sides. On the left it cancels. I have x equals 0 plus 10, which is 10. For this one, x minus 1 equals 0. I'll add 1 to both sides. Now I have x by itself. X equals 1. I've seen a lot of strange ways of writing this. These are two x-intercepts. So if this helps you, it's 10, 0. These are the coordinates of the x-intercepts. Those are the solutions to this quadratic function. And if you don't believe me, you can go to your calculator and type it in, which is exactly what I'm going to do. Go to y equals and clear this out and put it in as exactly as it appears. X minus 10, close parentheses, open parentheses, x minus 1, close parentheses. And let's just look at the graph. Need to zoom out. All right, and what we want to know is, where is this thing crossing the x-axis? Right there and right there. Now there's multiple ways of getting to this, but one easy way is to just go to the tables, second graph. Now look, we want to know what is going on with x when y is 0. So there's two places where you'll find it. Here's one. There, x is 1, and then go down until you find another 0. Bingo. X is 10. So it's when y is 0. I mean, look at the graph. See, this is the y-axis right here. And right on the x-axis, y is 0. So those 2 points are 1, 0 and 10, 0. And those are the solutions to this quadratic function. So we'll go back to our work surface. These are the two things that need to be in some kind of a box. Remember, with quadratics, the rule, the fundamental theorem of algebra, is there's always going to be, at a minimum, 2. Now, they might be imaginary numbers, but there's going to be at least 2 solutions. Okay. Now, this number 7 asks us to solve this equation right here in between my hands. There's a couple things we have to pay attention to. Right away, your eyes should be drawn to these -1 exponents. There's something weird going on there, and it actually helps to go back up and connect that to our negative reciprocal information. If I just cover up the negative symbol, I have m to the -1. And remember what we did there? We flipped. First we flipped the fraction, and then we put that negative sign. Well, now down here on number 7, I don't have any negative signs. I've just got some number raised to the -1. So I'm going to flip the fraction. So it's kind of like this. I have 4 to the -1, okay, which is 4 over 1. And so the inverse, or the inverting, or the reciprocal of 4 over 1 raised to the -1 power is 1 over 4. And likewise, I have here 1 over 16, because look, 16 is in the denominator position, raised to the -1. So I'm going to flip it. So that equals 16 over 1. Notice something. The 4 moved into the denominator, and the 16 moved into the numerator position. So they just flip. The whole, when you see these two are going to both flip. They're going to change positions. The 4 is going to come down here, and the 16 is going to go up there. So we'll come over here and start working with that. The first thing I'm going to do is flip the 16 and the 4 and put 16 over 4. And now I've got to deal with these x values, x to the 7 halves and x to the 5 halves. Okay, so now we need to apply the division rule for exponents. Well, some of you may be wondering, what is the division rule for exponents? The division rule for exponents, I'll write it over here, division rule, is x to the a, just x raised to some number, over x to the b equals x to the a minus b. So let's keep that in mind as we do this problem. Okay, so first of all, we can take care of this. What is 16 divided by 4? It's 4. Okay, so don't forget about the other side of the equal sign, but right now I just want to simplify this down. 16 over 4 is 4, so let me just write this equals 4. All right, so that takes care of that. And now I want to deal with these x values. I've got x, and what I'll do is apply this rule. X to the a minus b, where 7 over 2 is the a value, and 5 over 2 is the b value. So I just have x raised to the 7 over 2 minus 5 over 2. Okay, so what is 7 over 2 minus 5 over 2? Well, they have a common denominator, so you can just subtract the numerators. 7 over 2 minus 5 over 2 is the same as saying 7 minus 5 over 2. And 7 minus 5 is 2. So it's 2 over 2. Well, now, so I'll write that and show you. Got 4x raised to the 2 over 2. Well, 2 divided by 2 is 1. So I have x to the first power. And that's just x. So it's just x. So 4x to the 2 over 2 is just 4x. Because it's 4x to the first power. 2 divided by 2 is 1. So 4x. Now we can bring in equals 4 over here. So 4x equals 4. That's the problem I want to solve now. This problem right here. So I just want to focus on this. I want to get x by itself. And to do that, I will divide both sides by 4. On the left side, the 4's cancel out. And on the right side, I have 4 divided by 4. Well, 4 divided by 4 is 1. So that means, we'll put a little semicolon, so that means x equals 1. And that's the solution to this. Okay, moving on to number 8. Umberto sells 4 hoodies and 3 hats for $87.25. The next day, Omarion sells 10 hoodies and 2 hats for $164.50. How much is one hoodie? How much is one hat? We've seen this countless times. This is a system of equations problem. And while it is possible to solve this algebraically, this is one place where the astounding technology at your fingertips can help you. And we're going to use the matrix to help us solve this. So that's when you see a problem that looks like this, think matrix. All right, so we'll talk about what that means. This is a TI-84 skill, and we'll go over it. But first, we kind of have to set it up. So as we've talked in class, we have a little template. So set your template up. It's something box plus something box equals something. Over something box plus something box equals something. All right, and we'll fill this in as we read. So we're going to be active readers here. First of all, we have to say Umberto. So we'll give this H. So this is going to be about Umberto. What did Umberto sell? Umberto sold 4 hoodies. So 4. And then since hoodies and hats both start with H's, we'll write like hood. 4 hood plus 3 hats. So 3 hats. 3 hat equals, now how much did he make? $87.25. So 87.25. Right, now second line, Omarion. O for Omarion. He sells 10 hoodies. 10 hood plus, how many hats did he sell? 2 hats. 2 hat for, or equals, $164.50. 164.50. Now, you could take this and stick it into your matrix editor right now, but it sometimes helps to create a little 2 by 3 table. So that's 2 rows and 3 columns. So this is our matrix table that's going to help us with the data entry so we don't make any mistakes. Okay, you now have 2 rows and 3 columns. All we're going to do is copy the information down. So in this top left position, I'm going to put a 4. And then I'll put a 3. And then 87.25. So 87.25. Bottom row, 10, 2, 164.50. This goes into the calculator. So I'm going to jump screens now, but you're going to keep this on your paper in mind. We'll go to the matrix editor. Okay. In order to do that, I want to completely clear the memory, just so everything is nice and clear for you. And I'll even clear this key press history. So if you're using your own calculator, you can watch down here and see what I do. So I'm just going to hit enter to get back to that home screen. And let me clear that key press history again, just so this is totally clear about what we're doing. You'll click second matrix. Okay, second matrix. Right arrow, right arrow. Now you're on edit. Click enter. Okay, right here. It wants you to create a matrix table. Now ours is 2 rows by 3 columns. So hit 2, enter. 3, enter. And you'll get this symbolic form that looks like your table that you already filled in. So now we'll fill in this table with the values that we had. 4, enter. 3, enter. 87.25, enter. Now you're on the second row. 10, enter. 2, enter. 164.50, enter. Okay, so now you've entered all the data. We now have to click second and then quit. So that's the mode button. Second quit. Now we're back on the home screen. Now go back to the matrix editor, back to the matrix screen by clicking second matrix. This time we'll hit the right arrow to math. And we're going to scroll down until we see the letter B, R, R, E, F, open parentheses. So click enter. Once you're on R, R, E, F, click enter. And now you're on the home screen here with RREF open parentheses. Okay, we're really close to being done. The final step is to click second matrix again. You should be highlighting this first row, enter, and then enter. And here's the output. So I'm going to write this output down, and so are you. 1, 0, 14.5, 0, 1, 9.75. Okay, so I'll now flash back. This is all the data we need from the calculator. Let me flash back to our work surface so we can interpret it. Okay, the question is, which goes with which? $14.50 is the price of something, and $9.75 is the price of something. So here's the best way I've able to explain this. Hood came first. Okay, so $14.50 is the price of a hood. And then came hat. Hat came second. Okay, hat came second. $9.75 is the price of a hat. So this is the hoodie. And this is the hat. Those are the prices. Of one hoodie is $14.50, and one hat is $9.75. And you can just put that in a box. And that's the first page. Flip over. And let me tap, tap, tap. All right. Number 9. If the initial temperature is 32 degrees Fahrenheit and the heating rate is 15 degrees per minute, what is the temperature after 5 minutes? There's a lot of things that are triggering in your head right now to make you think this is an exponential function. Okay, it's an exponential growth function. Okay, because it's heating, right? So heating means it's getting hotter, temperature's going up. So exponential growth, we know we're going to be looking at something that looks like this, that exponential growth curve. Okay, so we need to write down the basic formula for exponential growth. If you can't remember it while you're doing this, look around on your test, because your test, the first page, had an exponential growth function right here, right? Future value equals present value times 1 plus r, close parentheses, raised to the t. Okay, so you can use this as a template if you can't remember, but ideally you will remember. This is one of those things that it does help to remember. Okay, so what I can say is future temperature, future temp is equal to the initial temperature, and I'll abbreviate initial init temp. Initial temperature multiplied by 1 plus the rate of growth. So the rate of growth is 15% per minute. But we don't put 15 in there, we put 15% as a decimal. Now 15% as a decimal is, what you do is put a decimal point after the 5 and move it to the left 2 places. 15% is 0.15, so 1 plus 0.15, close parentheses, raised to t for time. All right, and that is just a more contextualized way of writing the future value equals present value times 1 plus r raised to the t. I've just substituted in temp to make it more aligned to this problem. Okay, So the initial temperature, we're going to fill this in now with real data. Okay, put an equal sign and fill in what you got. Initial temperature is 32 degrees. So write 32 times, open parentheses, 1 plus 0.15, close parentheses, raised to time. How much time? 5 minutes. So put a 5 there in the exponent place. So in a way, we could actually think of this as f of 5. Do you see? I replaced the time with a 5, f of 5. Just like on that other problem, I had f of x, and then I did f of 0, because it wanted me to evaluate it where x is 0. Well, now I want to evaluate it where time is 5. Okay, so we're going to do this on the calculator. Let me flash to the calculator real quick. And get out of this, clear the screen. And again, we can do this one of two ways. We can just enter in 32, open parentheses, 1 plus 0.15, close parentheses, raised to the 5. Okay, type that in and click enter. And that gives you the temperature after 5 minutes. 64 point, and then I didn't say how many digits to round to, but let's just round to the 10th place. 64.4. If you had 64 point anything, I accepted the answer. Anyway, here's another way to solve it. You can go to y equals and put in 32 times, oops, you didn't have to put the time symbol. You could just put open parentheses. 1 plus 0.15, close parentheses, raised to the x. Raise it to the x. And then click second graph. And scroll down to see where x is 5 for 5 minutes. And there's your value again, 64.363 or 64.4 degrees. So whichever way you want to solve this, that's fine. Just make sure you get 64.4 degrees Fahrenheit. I'll now flash back to our work surface. Okay, and I've written down 64.4 degrees Fahrenheit. This is the box value. Right? Number 10 is just another exponential function. Starting salary. See up here I had the initial temperature. Now I've got the starting salary. There's all these synonyms for present value, initial value, starting value. Starting salary is $8.50 per hour at Taco Casa. Each year the hourly rate increases by 2.5%. What is the hourly wage after 9 years? All right? So a couple things. I need to write out future wage or salary, future wage is equal to the present or starting salary times, open parentheses, 1 plus, now I need to find the rate. Well, the growth rate here, because it's increasing, it's a growth rate, is 2.5%. So I've got to change that to a decimal. Put your pen or pencil on the decimal and move to the left 2 places. So you're going to have to put a 0 in there. So it's 2.5% is 0.025. So I'll put here 0.025, close parentheses, and it wants to know, after time, right? So raised to the t, FV equals PV times 1 plus r raised to the t. So now we'll just put in future wage is equal to the present or starting salary, which is $8.50 per hour, okay, times, open parentheses, 1 plus 0.025, close parentheses, and then for time, I actually want to put 9 for 9 years. So put 9. Okay. Now, this is the same thing as computing f of 9. So we're going to find the hourly wage after 9 years. So we go to our calculator. And again, we can put this in one of two ways. We'll just put in 8.5 times, you don't have to put the time symbol. I keep forgetting that. You can just put in the open parentheses, 1 plus 0.025, close parentheses, hit this little caret symbol or house or whatever, and then put in 9 for 9 years and hit enter. And you get $10.62 per hour. $10.62 per hour. Okay, another way of doing that is to go to y equals. Okay, clear this out. Put in 8.5, open parentheses, 1 plus 0.025, close parentheses, raised to the x. We can see for every year now, not just 9. Then hit second graph and look at where x is 9 years. Okay, 10.62. So two different ways of finding the same thing on the calculator. Flash back to our work surface. I've written down $10.62 per hour. Put that in a box. Move on to number 11. The question is 1 2/5 comma negative 12/3 in the solution set of this linear inequality? So this is a linear inequality because I'm looking right there at that inequality symbol. The first thing I need to do is get y by itself, and then I'll sketch a graph, shade it correctly, and plot this point to see if it's in the shaded region. That's the solution set. So what I want to do is get y by itself. I'll subtract 3 from both sides. And it's good to put the -3 if you have a number by itself, put it underneath that number. Okay, 3 minus 3 is 0, so that's gone. And then I have negative 7y less than or equal to negative 18 minus 3. So negative 18 minus 3, it's getting bigger in the negative sense. So it's negative 18, negative 19, negative 20, negative 21. So negative 18 minus 3 is negative 21 plus 28x. You see this is out of order. That 28x should be up front, and we'll change that here in a second. For now, it doesn't matter. So now I need to get y by itself, so I'm going to divide everything by negative 7. Divide everything by negative 7. And because I'm dividing by negative 7, I'm going to have to flip the sign. So negative 7 cancels out on the left. I have y by itself. It's always a fun moment. Now flip that sign. Y is greater than or equal to, and now we have to do some division. Negative 21 divided by negative 7 is positive 3. And now positive 28 divided by negative 7 is negative 4, and that's multiplied by x. So y is greater than or equal to 3 minus 4x. We don't like to write it like that, so we're going to write it in the correct form where we put that negative 4x up front. So now I've got y is greater than or equal to negative 4x plus 3. because it's positive 3. Okay, so now I'm going to shade this. I'm going to graph and or sketch and shade this. And now we're basically doing a problem just like number 4. Okay, we're going to sketch and shade. See? We're going to sketch it and shade it. All right, so we need to draw us a little graph here. Think about your y-intercept. It's going to be at positive 3, and then we have the slope m equals negative 4, and it helps to write over 1, because that's the rise over run, negative 4 over 1. So this is the rise. It's really more like a fall. So we're going down 4, and then running to the right 1 each time. Down 4 over 1, down 4 over 1. Okay, so we will start by labeling our axes and the origin, and then I'll put in some tick marks. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just that it doesn't have to be a masterpiece. Okay, so now we got to examine this inequality symbol. What are the features of a greater than or equal to sign? So here is the greater than or equal to. This is greater than, I'm just writing it, greater than or equal to. Greater than or equal to. What I'm dealing with, I have a negative slope, so I'm going down the mountain. I've got greater than or equal to, so I have a solid line, okay, with filled in dots. And it's greater than or equal to, so I'm shading above that line. So I'm shading above the line. There's your guide. So make sure your line is going to end up being a downward sloping line shaded above the line. That's solid. So we start plotting at x equals 0, y equals 3, because that's the y-intercept, 3. So you start here and go up 3. 1, 2, 3. You can put a closed dot right there. And now we're going to play our rise over run game. We're going to go down 4 over 1. So down 1, down 2, down 3, down 4, over 1. Okay? We only need 2 points. We can just slide our ruler in there and connect those dots. And remember, it's going to be a solid line. And we are shading above that line. So above in this sense becomes somewhat ethereal. I always think about plane wings, right? So a plane's flying, and sometimes a plane goes like this. Below the wings would be shading down, and above the wings would be shading up. So even when it's a really steep line, you know it's above the line. Okay, so now we have to figure out if these coordinates are in the solution set. We got to convert 1 2/5 into either a decimal. It would help to convert it into a decimal in this sense. So if you don't know how to do that, what we need to do is first we need to convert 1 2/5 into an improper fraction. So I've got 1 2/5. Okay. The way you convert it to an improper fraction, multiply the denominator by the whole number and add the numerator. So 5 times 1 is 5, plus 2 is 7. So this equals 7/5, 7 over 5. Now I've got negative 12/3 as well. I got negative 12/3. And I need to know the decimal forms of these numbers. Okay, so if you don't want to do it by hand, your calculator can help you here. Just flash over to the calculator really quickly. Get home, clear the screen, and now hit alpha y equals, enter, and just put it in. 7/5, okay, enter, and then math, and we convert the fraction to a decimal, 1.4. So we'll write that down, 1.4. And then negative 12 thirds. Again, if you can't do that in your head, just put alpha y equals, and then negative, not minus, negative 12 thirds. Okay, it already converted it. See, it's negative 12 divided by 3 is negative 4. So it just converted it for us, negative 4. So our coordinates are 1.4, comma, negative 4. We'll flash back to the screen and look at our work surface. I want to know if these coordinates are in this solution set. So here's how this works. You go over 1.4, which is like halfway between 1 and 2, okay, and then you go down 4, down 1, down 2, down 3, down 4. Okay, right there. I am outside the solution set. So that is right there. That's where that point lives. It's just below the line. Okay, but because it's not in the shaded region, it is not on our graph. And we can throw it out. If you weren't sure about this and you wanted to be extra certain, what you could do is go back to your calculator. We're going to be playing a little bit of a game here with this negative 4x plus 3. Let me show you how to do this. Go back to your calculator, go to y equals, clear that out, and put in negative 4x plus 3. Okay, enter it in just like that. And then hit second graph. Okay? Now, you'll notice something. We do not have 1.4 as an x value, and we do not have negative 4 as a y value. So what to do, what to do? Well, we have to remember second window. Click second, then click window. This is our friend. Go down and change independent, which is the x, from auto to ask. And now it's going to ask us, what x do you want to know the y for? Okay, and then click second graph again. You'll be looking at this blank table. Now you can put in 1.4. Okay? It says it's at negative 2.6. Okay, so according to our function, when x is 1.4, y is negative 2.6. So we know if negative 4 had been on the line, it would have shown up. Okay, or we would have seen a value of greater than negative 4 here in the y. See, if we go to the graph and look at the graph, we can see. What I can do is actually graph. Let me show you something here. Let's look at the x value and the y value. Let's see if we can't get over to approximately 1.4. That's close. And then put y at negative 4. Do you see that? It's just below the line. It's not in the solution set because this whole region is shaded. And that's how we know. That's how we know. So multiple ways of getting at the answer. It's always good to know a variety of tactics. Let's just flash back to the work surface. And the question, I remember what the question was, is this in the solution set? And so really, the answer is no. Now, look. What I saw on many tests was that no in a box. I didn't see any work here. I didn't see any graph. None of this, right? Nothing to defend the answer. It was like people were just taking a shot at it, yes or no, right? Maybe yes, maybe no. I got a 50-50 chance, so I'm going to write one or the other. But this is how you find out for sure. Okay. Number 12. simplify. Okay, evil word. It always seems like the simplification problems are hard. Luckily, this one is not hard. Okay, we're going to simplify this, and we're basically going to be applying the division rule over and over. Now, before I start working on this, as a good little math student, I'm going to go in here and check these. I'm going to go in here and check these exponents. All right, and I notice that C on the bottom doesn't have one, and I know that that means there's a 1 hiding there, and I'm going to need that. That's going to be useful. Now remember, the division rule for exponents, we're going to be using that over and over here. Division rule. So x to the a over x to the b equals x to the a minus b. All right, so I'm going to be using that over and over again, because I have a to the 9th over a to the 9th, b to the 7th over b to the 6th, c to the 3 over c to the 1. So first things first, I'm going to deal with these whole numbers. 8 divided by 4 is, for some reason, a lot of people are writing 4. 8 divided by 4 is 2. Okay, so 8 divided by 4 is 2. And now I'm going to write a, because that's the first exponent. So I've got a to the 9. I'm going to follow this. X to the a over x to the b equals x to the a minus b. So a to the 9 over a to the 9 equals a to the 9 minus 9. Okay, multiplied by b. So times b. Bring that guy in here. B to the 7th over b to the 6th equals b to the 7 minus 6. Times c. C to the 3 over c to the 1 equals c to the 3 minus 1. That's the process in your brain. So write it out like that, and you'll never go wrong. This equals, we're going to finish this off. I got 2a to the 0, because 9 minus 9 is 0. We'll figure, we probably already know what that means, but we'll get back to it. And then times b, 7 minus 6 is 1. Okay, we'll get back to that, what that means. Times c, 3 minus 1 is 2. Okay, now, a couple of things coming into play here. The zero exponent rule is at work right here. Remember the zero exponent rule. Anything raised to the 0 power is 1. So a raised to the 0 power must be 1. So further simplification, 2 times, and I'm going to replace a raised to the 0th power with a 1. 2 times 1. Okay, times, now b to the first power, we don't have to write that 1. It's just understood. So we could just write times b. Okay, and then times c to the second power, c squared. Okay, and if this is correct, but one final simplification will make it look really nice. 2, and you can drop all these multiplication signs because the multiplication is understood. 2bc squared. 2bc squared. Okay, put that in a box. And again, on your work, I want you to write the division rule. I mean, if you missed this problem, you probably didn't apply that division rule correctly. So write it down. The only way you will remember these rules is by writing them down over and over again until it's just part of your working memory. Okay. Number 13, x to the 3 raised to the 4th power divided by x squared raised to the 1/2 power. Okay, now this is a new rule. This is not the division rule. It's not the zero exponent rule. It is the power rule. We'll review the power rule here. So the power rule. What is the power rule for exponents? Okay, if I've got x to the a, parentheses, raised to the power b, this is equal to x to the a times b. This is where you get to multiply the exponents, when you've got one exponent raised to another exponent. So we will take x to the 3. We'll do it over here. I got x to the 3 raised to the 4th power is going to be x to the 3 times 4. Okay? And that is divided by, we'll deal with the division later, x to the 2. So put x to the 2 raised to the 1/2 power. So that's 2 times 1 over 2. So 2 times 1/2. That's what I'm dealing with. Okay, so let's further simplify. X, now 3 times 4 is 12, so it's x to the 12th power divided by, now think about this, I got 2, which can be written as 2 over 1. 2 over 1 times 1 over 2. Okay, 2 times 1 on top, I got 2 up on top, and then 1 times 2 on the bottom. 2 on the bottom, I got x to the 2 over 2. Well, 2 divided by 2 is 1, so that's x to the 1. So x to the 2 times 1/2 is x to the 2 over 2, which reduces down to x to the 1. So I can just write x to the 1 power. Now I've got to divide x to the 12th power divided by x to the 1 power. So it's better to write it as a fraction. X to the 12 over x to the 1. Now we're going to apply the division rule. X to the a over x to the b equals x to the a minus b. So this is equal to x to the 12 over x to the 1 equals x to the 12 minus 1. You just have to follow the logic of the problem, and you get x to the 12 minus 1 is 11. So it's x raised to the 11th power. And that's the answer. Number 14. F of x equals x squared plus 9x plus 14. Okay, so here's how you factor these simple quadratics. You need two numbers that add to the middle term. The middle term is positive 9. They add to be 9. And those same two numbers multiply to be the last term, which is 14. Okay, so I need two numbers that add to the middle term and multiply to the last term. So this is where we start playing in our heads. What two numbers multiply to be 14 that might add to be 9? Well, the only factors of 14 I can think of are 1 and 14, which add to be 15, and 2 and 7, which add to be 9. So the answer is 2 and 7. 2 plus 7 equals 9. 2 times 7 equals 14. Now, a lot of people stopped right here, and I was proud of you for getting this far. If this were a multiple choice test, you would probably be able to get the answer from here. But what I'm actually looking for you to do is to write this in the factored form. The factored form would be f of x equals open paren, close paren, open paren, close paren. And I've got x and then plus something, plus something. In this case, it would be plus 2 and plus 9. So the factors are x plus 2 and x plus 9. Okay, so that's your answer right there. That's the factored form of that quadratic. So if you put this in the calculator, x squared plus 9x plus 14, and then you put this in the calculator, they would be equal to one another. You're just writing it in a different way. It's like you've got standard form equations and slope-intercept form equations. So this is standard form quadratic, factored form quadratic. All right? Incidentally, what are the solutions to this quadratic? Well, if x plus 2 and x plus 9 are the factors, you know the solutions. You just solve for x. So you set x plus 2 equal to 0. And you solve for x. X equals negative 2. And then you do the same thing for x plus 9. X plus 9 equal to 0. So x equals negative 9. So negative 2 and negative 9 are the solutions. Now that's extra. That's a bonus. That's extra. You don't need that right now for this problem. This is what you need. But just so you know, you can always go from factors to solutions real quickly. Okay, number 15. Factor f of x equals x squared minus 4x plus 4. All right, so there is nothing different here. We're just going to play our little game. Okay, it's really like a game. It's like Sudoku. They have to add to equal the middle term, which in this case is negative 4. And these terms have to multiply to equal the last term, which is positive 4. So we just have to play our little head game now. What two numbers multiply to be positive 4, but add to be negative 4? Well, what are the factors of 4? 1 and 4. 1 plus 4 is 5. How about negative 1 and negative 4? Negative 1 plus negative 4 is negative 5. So that's now good. I want it to be negative 4. What are the other factors of 4? Oh, 2 and 2. 2 plus 2 is positive 4. That's no good. So how about negative 2 and negative 2? Okay, and that turns out to be right. Negative 2 plus negative 2 equals negative 4. And negative 2 times negative 2, negative times negative, makes a positive 4. So those are the factors. So you could write x minus 2 in parentheses and x minus 2. You could write it like that. There's nothing wrong with that. But you could, like the pro game is to recognize that x minus 2 and x minus 2 are the same number. This is the same thing, right? So another way to write that, you could say, or you could write this as x minus 2 squared, right? So I'll box these in, but just for those people who are playing this game at a little bit of a higher level, you could rewrite this equation as f of x equals, open parentheses, x minus 2. I just wrote a plus sign for some reason. X minus 2 squared. Okay, but this is the boxed answer is just fine. So in this case, your solutions are both at 2. So it's x equals 2 and x equals 2. So this one had exactly one real solution. All right. Simplify this. Again, simplify. This is number 16. Simplify, always seeming to be more difficult than the word simplify would imply. But that's okay, we can do it. We have to deal with this in pieces. So the first piece we're going to deal with is the numerator. So I'm going to deal with the numerator. Let me write that out. 72 x cubed minus 24 x squared. Okay. Now, we have to think, what can we factor out of this expression? What I'm asking is, I've got two terms. I've got 72x cubed, and I've got 24x squared. So what can I factor out that's common to both terms? Well, think about this. You got 72 and 24. What's the greatest common factor between 72 and 24? Well, it would be 24, because 72 divides by 24 into a whole number, and 24 divided by 24 is just 1. So I could divide both of these by 24. So we kind of pull it out. You factor out a 24. Okay? Factor out a 24. Leave a little space here because you're going to factor something else out. Now, what's common with the x's? Now this requires you to think about the multiplication and division properties of exponents. So, what can I take out of both? Well, you just think, what is the greatest common exponent? Well, here I've got threes. Here I've got 3 of the exponents, and here I've got 2 of the exponents. So what I could do is I could divide x cubed and x squared by the greatest common exponent, which would be x squared. Okay, follow me with this. So we're going to pull that x squared out. All right, so now I've got 24x squared sitting outside. And let's see what's left inside. So we get down here, right, 24x squared, open parentheses. Now 72 divided by 24 is 3. So put 3. And now we have to use our division rule. X cubed divided by x squared. Remember, x to the a divided by x to the b equals x to the a minus b. So x to the 3 divided by x to the 2 equals x to the 3 minus 2, which is x to the 1, or just x, 3x. Okay? And now we can subtract out, and now we put a minus sign, and we have 24 divided by 24 is 1, and x squared divided by x squared is 1, because x squared over itself is just 1, so I just write a 1 right here to replace all that, and then close the parentheses. Okay, so now I'm going to rewrite this as 24x squared, open parentheses, 3x minus 1, close parentheses, all over x minus 1. Okay? And that is the simplified form of this expression, or the factored form of the expression. So you put that in a box. All right, on to number 17. What is the domain and range of this negative sloping quadratic function? Okay, so it's pointing down. It's pointing down. And the thing is, and this is just something we're going to have to learn, domain for a quadratic function is infinite in both directions. So let's go over here and get the domain right away. Put an x for the domain and a y for the range. I saw people putting numbers in here. This is where the x and the y go. Now, what is the lowest value that the domain can be? That's the x-axis. See, they didn't label the axes. That would have helped. So on the x-axis, what is the lowest it can be? People are getting hung up on these numbers. Okay, those are the zeros of this equation. They have nothing to do with the domain. Nada. Okay, so this is negative infinity off to the right, or the left, and positive infinity off to the right. So we'll put negative infinity less than or equal to x less than or equal to positive infinity. This is just a property of quadratic functions. You've got to remember it. Now, how about the range? The range is going to be infinite in one direction, but then it will have a maximum or a minimum value. Because this is a negative sloping quadratic function, the vertex is up on top. So we have a maximum point, and that's at y equals 4. So it goes down, 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 way down into negative infinity. Less than or equal to y, less than or equal to the maximum value that y can be, okay, which is where y equals 4. Can't go any higher than that. That's the upward threshold. So I put a 4 right here. And that's the answer to number 17. Number 18. find an equation of the line perpendicular to 6x minus 2y equals negative 12 passing through 4 minus 2. Okay, this is an old school algebra problem. And what we need is to take our time and think about what we're doing and just solve this thing out. So the first thing I want to do is highlight the word perpendicular, because I'm going to do some work here just to get this out of standard form into slope-intercept form so I can identify what the slope is of the original line. And then I'm going to have to find the negative reciprocal slope, and then I'm going to have to use the point slope formula to find where it passes through 4, 2, the perpendicular, okay, line. So first things first, we got to get y by itself. So subtract 6x from both sides, right? Cross that out. Now I've got negative 2y equals negative 6x minus 12. Okay, and I'll just divide both sides by negative 2y, or negative 2, sorry, negative 2. Okay, on the left they cancel, and I'm going to move this y over here, so y equals, and we'll start working, negative 6x over negative 2. Okay, negative 6 divided by negative 2 gives me positive 3x. Negative 12 divided by negative 2 gives me positive 6. Okay, so I've got y equals 3x plus 6. This is the equation of the given line. Now, y equals mx plus b. Okay, that's the mx plus b. So the slope of the original line is 3 over 1. So we'll play our little game, you know. I'm going to use this space here because I don't want to run out of space. I say if m equals 3, and it would be helpful to write this as 3 over 1. Okay, rise over run, 3 over 1. If m equals 3, then the negative reciprocal of m equals flip, and change the sign. Flip and change the sign. Just do it without thinking. So 3 over 1 becomes 1 over 3, and change the sign. Put a negative. There it is. So the perpendicular slope to this is negative 1/3. Okay, so now we have to use the point slope formula to find an equation of a perpendicular line passing through those points right there, that point right there. Okay, so we got to remember what the point slope formula is. Now, luckily, it's in the front of your STAAR test booklet. If you look at the references page, it'll be there. So, but if you don't remember the point slope formula, this is one of those things that would be really helpful to remember, is y minus y1 equals m, open parentheses, x minus x1, close parentheses. That's the point slope formula of a linear equation. So now it's a game of fill in the blank. Okay, I'm just going to carve off a little space here to work in. The point we were given is 4, 2. So we got a point and we have a slope, m equal to negative 1/3. So we can do this, guys. We can do this. Now 4 is going to be our x1 and 2 is going to be our y1. So we're just going to fill in the blanks right here. This will move down to this space right here. Y minus, now represent y1 with 2. Y minus 2 equals m, represent m with negative 1/3, negative 1/3, open parentheses, x, okay, minus, represent x1 with 4, close parentheses. Okay, if you get this far, you're going to get it right. You just have to use your mind, follow PEMDAS, and everything will take care of itself. Now you're going to try to distribute negative 1/3 through this parenthetical expression, and then get rid of the negative 2 on the left, so get y by itself. So let's do that in steps. First, we will distribute negative 1/3 to x and negative 4. So we'll rewrite y minus 2 equals, and then I'll multiply negative 1/3 times x is negative 1/3 x, and negative 1/3 times negative 4, okay, just think about this, negative 1/3 times negative 4 over 1. So negative 1 times negative 4 equals positive 4, and then 3 times 1 equals 3. So it's going to be 4/3, right? So I've got positive 4/3 plus 4/3. Now I have to add 2 to both sides to get rid of the 2 on the left. Now I'll have to move over and write y equals negative 1/3 x, and now I've got a problem. I have to add together 4/3 and 2. We need a common denominator, all right? So we have to find a common denominator, and that common denominator is going to have to be 3. So we need to multiply 2 times 3 over 3. 2 times 3 is 6, so 2 can be rewritten as 6/3 because 6 divided by 3 is still 2. So now we have this other little problem. I got 4/3 plus 6/3. It's a little side work. 4/3 plus 6/3, common denominators, you can add the numerator. 4/3 plus 6/3 equals 4 plus 6 over 3. That's 10/3. Okay, so you can bring that down. Y equals negative 1/3 x plus 10/3. Okay, that is the equation of the perpendicular line passing through 4, 2. Okay, number 19. In a sequence defined by the function f of x equals 2x plus 1, what is the 11th term? Okay, what you're going to compute here is f of 11. Most people got this right, so I'm not going to spend a lot of time on this. That's equal to 2 times 11 plus 1, okay, which is equal to 22 plus 1, which is equal to 23. Now, if you didn't know that, you could have gone to the calculator, gone to y equals, clear this out, and put in 2x plus 1, and then hit second graph. We got to change that second window table setting back to auto. If you can't remember how to do that, just clear the memory. Now second graph again. Scroll down to where x is 11, and you'll see it's 23. Okay, so either way, whichever way is the most comfortable for you, you can find out that the 11th term in the sequence is 23. And that's what you box right there. Okay, so we can circle that out of 19 actual problems, we got 19 correct. Fantastic. This was more of a to see where you thought you were, and most people were very honest, which was good. I was happy to see that you were accurately gauging where you were. This wasn't just a pointless 20th problem. I want you to get in the habit of asking yourself, which ones do I know I got right? Because on the STAAR test, you'll want to count up the questions you got right. And what you're looking for is you're looking to hit that magic number. Okay? We definitely want to get 21, but if we can get 25, we are really sure that we're passing. So in this case, 19 is all of them, so 19 would be like 100. Okay, so I hope that you watch this video and that your paper now looks like mine. Okay? Look at it, it's just filled with work. Filled. And practice makes perfect. So look, this is what I'm going to say to you. Ultimately, your education is in your court. What you do with this, video, if you are fast forwarding to the answers and writing them down and then skipping to the next answer and writing it down, then you could probably fool me into thinking that you did your test corrections. Okay? But you haven't fooled yourself. And ultimately, that STAAR test is between you and yourself. So look, can you cheat and watch this video and just write it down and not pay attention and not work the problem out? Yes, you can. And I might not be able to figure that out, but it will show up on the next test. And that's why these grades were so low, because on the review video, okay, where all these solutions are shown, I mean, the review is almost identical to the test, just the numbers are changed. Look, here's the review. Here's the test. Okay, they're very similar. So what was upsetting was that it seemed like everybody got the review correct, because the review corrections were all perfect, as if, you know, you guys had gotten it all. And then on the test, it was a faceplant, you know, for a lot of people. It was, you know, got 1 right, 2 right. And I'm not here criticizing you. I'm not criticizing you, but I'm asking you to ask yourself, when you did those review corrections, did you really do them? Or did you just scroll to the answer, write it down to get that test correction grade, the review correction grade to go up? Now, I know sometimes you're in a hurry, and I know sometimes you just don't have the mental energy. Believe me, I know. But it's time to buckle down, all right? If there was any time during the year to get serious about math, it's this time of year. Let's get through this thing, all right? And then we can be done with it. And you can kind of enjoy the math, right? And listen, I use a lot of colors. You see that when I do these? Because it's kind of boring if I just use the one color. So I like to use a lot of colors. Equip yourself with some map colors, some colored pencils, some markers. And I really like using these highlighters and different colored pens. Okay? This way it gets a little bit brighter, right? That's just something for you. And then I would also, you know, invest in some kind of straight edge. Could be anything. You could take a note card and fold it in half, right, to make a straight edge. So it doesn't have to be fancy, but just some kind of straight edge keeps everything straight, makes it look pretty. That way you can be proud of your work when you turn it in. And then if I were to ask you to defend your work, first of all, if somebody turned this into me, it would be clear that they knew what they were doing, because just look at the paper. It feels clear. But if I ask you to defend it, you would be able to go through and say, oh, yes, 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 here's what I did, right? So that's why we ask you to show your work. It's not like some kind of punishment. But this is really important right here. You've got to be able to graph this and shade that thing in so you can see that that little dot right there, even though it's super close to that line, isn't in the shaded region. So that's why good, clean, pretty work is so important to your learning. It's not about the grade. I don't care about the grade. I'm happy to give you just 100 after 100. It's whether you understand that I'm interested in. So I hope this video helped aid in your learning and understanding, and not just get your answers right so the test score goes up. That's not the point of these videos. The point is for you to understand more, and I hope this video helped you do that. Thank you.